Hi friends, welcome to ACE Engineering Academy presentation. To all the GATE aspirants, what is the preparation strategy for one of the most scoring subjects and one of the important subject of water resources engineering, the subject of engineering hydrology. Friends, when you have seen the previous papers of engineering hydrology questions from the previous papers of GATE, you might have seen minimum 3 marks, maximum 6 marks. Getting a minimum of 3 marks in the subject is not a easy thing. If you are able to plan, if you are able to read the subject is a very simple subject, we know. Most of you know. You have gone through the subject also. In this particular video, we are going to see what chapters you have to give concentration, in what areas you have to give concentration, that we are going to discuss. Please remember, the total GATE rank will be tilted over either positively or negatively, depending upon whether you have scored in engineering hydrology in the best possible way or in the worst possible way. If you are able to get the command over the engineering hydrology with reference to the GATE aspects, your GATE result will be highly positive, means very good rank is waiting for you. That's why my sincere appeal, don't neglect engineering hydrology. The revision of the subject will take only 3 to 4 hours on a happy Sunday evening after the serious preparation of the day is over. Relax after evening chai. Relax. Sit for 3 hours. You can go through the entire material you are having with you. Just scanning through the pages, whatever points of highlights or importance are given. By going through the points, you can understand. You can revise. You can get confirmed and reconfirmed about your thorough knowledge of engineering hydrology. Let us see what areas you have to give more concentration and less concentration. We'll see. First part is precipitation. For the hydrologic cycle, we can start from any point and end with any part of the hydrologic cycle. It is preferable to start with precipitation. For any system like the catchment area, we start assuming that inflow is the rainfall. Rainfall alone, rainfall and snowfall combinedly. Under precipitation, we got 3 chapters. One is fundamentals of precipitation, its measurement. How do you measure the precipitation? We will see what are the important areas of each chapter. Calculation of average depth of precipitation. Average depth of precipitation is second chapter. Third chapter is frequency distribution of point rainfall. These 3 chapters will come under the major subgroup of precipitation. Second major part comes under extractions, or simply we say losses. Under that fourth chapter, evaporation. In the chapter of evaporation, we learnt about evaporation, transpiration and evapotranspiration. Infiltration. How much is the infiltration loss? How do you calculate the depth of infiltration? What are the infiltration indices? What is their use? What is their advantage in calculation of what parameters they are useful, etc. We study in the chapter of infiltration. 4 and 5 comes under second part, that is losses. The third part, everything about the runoff. How do you calculate the runoff? What are the various methods available to estimate runoff? What characteristics are important? Each and every characteristic of catchment area will be having some influence on the runoff calculation. So catchment characteristics is one important point. Maximum flood estimation. Flood routing. Under the runoff we are discussing flood routing. River gazing. To study the runoff value, most important part of the runoff is construction of hydrographs. These chapters will be coming under the heading of runoff. If you take the subsurface runoff of that base flow linked with the groundwater hydrology, but generally well hydraulics or groundwater hydrology is separately we deal with. And the fourth, under groundwater hydrology, twelfth chapter, that is well hydraulics. So if you observe these 12 chapters, most important chapters, you must and should be thorough, theory-wise and problems-wise in the 5 chapters. That's what I want to mention. Average depth of precipitation, evaporation, hydrographs, well hydraulics, and you can say frequency distribution of rainfall. 2, 3, 4, 11, 12. From these list of the chapters, if you refer to some other source, the order of the chapters may change slightly. Take any question on GATE. These 5 chapters are very, very important for your preparation. What are the subtopics in each and every chapter? We'll see briefly. Even though the other chapters are of less important, some areas where the theory questions can be framed, we will just touch in the part of the preparation strategy for the subject of hydrology. In the first chapter, Precipitation, we will see the general basics of engineering hydrology. What is the existing water resources in India? What is meant by hydrologic cycle? What is meant by residence time? In a particular phase of the hydrologic cycle, how long the water will exist? In a particular phase of the hydrologic cycle, how long the water will exist, that is called residence time, is important. Then how do you measure rainfall? How do you measure snowfall? If you want to convert the snowfall into equivalent rainfall, that is rainfall equivalent, how do you get? By using, we know 10 centimeter snowfall is equal to 1 centimeter rainfall, taking the density as 0.1 gram per cc or 100 kg per meter cube. Then after rainfall, snowfall, what are the various methods of representation of rainfall data? What do you mean by intensity of rainfall? If you know the value of intensity of rainfall, 1 to 2.5 millimeter per hour light rainfall, 2.5 to 7.5 millimeter per hour moderate rainfall, more than 7.5 millimeter per hour heavy rainfall, such classifications are important for gate examination. What is hydrograph? Area of the hydrograph gives the total rainfall depth. So, if you are given the hydrograph, then you may be asked to calculate what is the average intensity of rainfall. Calculate the area of the hydrograph. You will get the total depth of the rainfall divided by total time duration of the precipitation. You will get the average depth of rainfall mathematically. What are the various methods available to represent the rainfall data? 3 are most important. One is hydrograph, intensity of rainfall versus time. Second one is MIC, mass inflow curve, accumulated mass of the water inflow versus time, forever increasing. If there is no rainfall for particular some time, you will get horizontal, but always it is increasing as long as there is a rainfall. Slope may be varying depending upon the variation of the intensity of the rainfall. MIC, mass inflow curve, is one important concept. Please recall, hydrograph can be converted from MIC. MIC can be constructed from hydrograph. Both are interconvertible. Both will represent the rainfall data in different terms. One is intensity of rainfall versus time. Second one is accumulated mass inflow versus time. Third one is aerial representation. Aerial importance. Aerial representation of the storm is indicated by DAD curve, depth, area, duration curve. These 3 are very, very important areas. In that particular first chapter, precipitation, most important is, number 1, how to represent rainfall data by 3 standard methods. Other 2 methods are there. One is the DDF curve, second one is IDF curve. They are not much important. Hydrograph, mass inflow curve and DAD curve are very, very important. Because the basic chapter, you must understand fundamentals of engineering hydrology, fundamentals of precipitation, at what time you will be recording the rainfall every day, 8:30 a.m. Such fundamentals, what is the average annual rainfall in India, in the entire globe, such theory questions also important. In the same precipitation chapter, you will come across how do you interpret the missing. First of all, before that, we go for about the rain gauges. How many optimum number of rain gauges you have to provide? Optimum number of rain gauges is also one important area. Already a number of stations are existing. and n number of stations are existing in the catchment. We got the rainfall data of those n number of stations, P1, P2, so on, Pn. Get their average value, get their standard deviation from the arithmetic mean and the standard deviation of the rainfall data. Calculate the coefficient of variation. Once we get the coefficient of variation, optimum number of rain gauge stations to be provided. Capital N is the symbol. Capital N is equal to CV by epsilon whole square. Don't forget these two formulas. How epsilon is the permissible error while the rainfall data is being recorded. Generally, IS code is permitting up to 10% error as acceptable error. Therefore, the two formulas, one is the coefficient of variation. Coefficient of variation depends on dash. Rainfall data of the already existing n number of rain gauge stations in the catchment area. Once I know CV, I know permissible error. CV is in percentage, epsilon is in percentage. CV by epsilon whole square will give optimum number of rain gauge stations. N is already existing. Capital N is the number of rain gauge stations to be provided. So how many additional stations? N minus N if N is greater than N. M is equal to 0 if N value less than or equal to N. Already 6 stations are there. You are permitting higher error. N value becomes only 5. Already 6 are there. 5 is sufficient. We need not restrict the 6th one, but we'll keep it as it is. The status of the rain gauge stations will be remained as it is. So, these particular points you can understand in the heading of precipitation. In the same precipitation chapter, one more point is important. In the same precipitation chapter, how do you interpret the missing rainfall data? By chance, out of 5 or 6 stations in the catchment area, one particular rain gauge station is inoperative for some time. A particular rain gauge station is inoperative while all other n-1 number of stations are operative. With the help of the rainfall data of the remaining surrounding stations, you are in a position to mathematically interpret the missing rainfall data by any one of the 3 methods: arithmetic mean method, normal ratio method, and inverse square distance method. The 3 methods you must थोड़ा सा practice करना चाहिए. You must have the little bit practice on the 3 methods: arithmetic mean method, regarding the interpretation of the missing rainfall data, arithmetic mean method, when the normal annual rainfalls are nearby, very close to each other within the 10% margin, then we can go for arithmetic mean method. P missing is equal to average of the remaining n-1 number of rain gauge stations rainfall values. Second one is the normal ratio method. When the annual rainfalls are differed by large more than 10%, and when you don't have the normal annual rainfalls, best method is ISD method. ISD method is also called inverse square distance method. It depends on the locations of the inoperative rain gauge station versus operative rain gauge stations. About most accurate method is inverse square distance method. Simultaneously, it's the most laborious method also. If the margin of the normal annual rainfalls is very, very less, go for arithmetic mean method. Otherwise, go for normal ratio method. Generally, we follow first or second methods depending upon the relative values of normal annual rainfalls of all the rain gauge stations in the catchment area. One more point we can observe in the precipitation chapter, we can observe one more important one is double mass curve. When n number of rain gauge stations are there in the catchment, if you get some doubt about the consistency of the data of the rainfall data of the particular rain gauge station, to check the consistency of the rainfall data of a particular rain gauge station, simple graphical method we are adopting, that is called double mass curve. If there are n number of stations, only one station is doubtful data. Take the accumulated rainfalls recorded by that particular rain gauge station on y-axis. Average of the accumulated rainfalls of the remaining n-1 number of stations on x-axis. If the graph is linear, data is consistent. If for some time, if the non-linear fashion is existing, it indicates that the rainfall data given by that rain gauge station is inconsistent. So, please understand, please recall, while you are preparing for engineering hydrology preparation in this particular strategy class, please understand double mass curve is the one which will check consistency of rainfall data as recorded by a particular rain gauge station over the number of years as compared to surrounding rain gauge stations rainfall data. That's all you have to prepare from the chapter of precipitation. Second chapter is the most important one. So many times questions have been framed. It's a very simple chapter. To calculate the average depth of runoff from the catchment, we should know average depth of rainfall. What are the three methods available to calculate average depth of rainfall? Three methods are there. One is the arithmetic mean method. Second one is the Thesian polygon method. Third one is isohydral method. When all the rain gauge stations are in the nearby area and less number of rain gauge stations are available, arithmetic mean method is best. Friends, we are discussing about second chapter, average depth of precipitation, a very important chapter for engineering hydrology. N number of stations are available with the recorded rainfalls. What is the average value? If you know average value P bar, I can get R is equal K into P. Average depth of rainfall into runoff coefficient will give average depth of runoff. Simplest way to get runoff. Three methods are available to calculate P bar, average depth of precipitation, arithmetic mean method, Thesian polygon method. Every catchment area, in the catchment area, every rain gauge station is given some weightage area. Depending upon the total area versus its weightage area, every rain gauge station is given some weightage factor. That is called Thesian factor, Thesian weightage factor, we call it as. Some of the Thesian factors of all rain gauge stations is one simple formula. P bar is equal sigma Pi xi. P is the precipitation recorded by each rain gauge station. X is the Thesian factor. You can get the value of P bar very easily. Third method is isohydral method. Isohydral method is the most accurate method and which assumes that catchment area is having infinite number of rain gauge stations. Mathematically, more number of times isohydral method is asked. Isohydral method. So divide the entire catchment area into number of convenient zones bounded by different iso heights. Average of the boundary iso heights into area. Average of the boundary iso heights multiply with the included area. Like that, you are going to calculate sigma Pi Ai by sigma Ai will give the value of P bar. Please recollect isohydral method, most commonly asked in GATE and most accurate method to calculate the average depth of precipitation. Second chapter is average depth of precipitation, very, very important. Need to be prepared thoroughly, the three methods, all possible problems from all possible sources. You must collect and get the problem solved, not to have any doubts. Because when you start solving different problems from different sources, you will be opening the new windows for the subject. Principle is same. What type of difficulty will come while attacking a problem? That's why your search will be always for typical theory questions and innovative numericals. If you go on concentrating like that, sky is the limit and your success is wonderful. Third chapter is also, I presume it's a very, very important chapter, knowing the past rainfall data, how to estimate about the future rainfall data. With the help of the distribution theories, here we use the binomial distribution. We know the probability of exceedance from the return period. What is the probability that a particular rainfall is coming at least R times in the coming n years? Only R times in the coming n years, not even once in the coming n years, at least once in the coming n years. What is the hydrologic risk? If you refer to all the things, from the past rainfall data, you can calculate the return period, for which generally we use Weibel's formula. Return period, we calculate the probability of exceedance, probability of non-exceedance, probability of exceedance equaling or greater than probability of non-exceedance. We are able to get only one basic formula, R times in coming n years probability of is equal to NCR P R times Q n minus R times. The general term of the binomial expansion, if you remember, the whole chapter is in your hands. What is meant by hydrologic risk? That is also commonly asked. If you put R value, at least R number of years, it is R times. At least R times, keep sigma symbol. Not even once, put R is equal 0, NC 0, P power 0, Q power n minus 0, Q power n is the formula. What is the probability of getting the particular rainfall equaling or exceeding? Not even once in the coming 10 years. Q power 10. Coming 20 years, Q power 20. Every year the rainfall should not be equalized or crossed. Every year Q like the 20 years. Q power 20 is the required probability to get a particular rainfall not equaling or exceeding. Not equaling or exceeding for the coming 20 years. Q power n, probability of getting the rainfall not even once. Q power n in the coming n years. Everything is based on this formula. Please don't forget probability of getting a particular rainfall equaling or exceeding R times in the coming n years. This is the formula. At least R times, at least once, put R0. Not even once, put R is equal to 0 in the entire equation. At least once, 1 minus not even once. What is the probability of getting the particular rainfall equaling or exceeding at least once? 1 minus not even once. Not even once, Q power n. So what is the formula for the probability of getting a particular rainfall equaling or exceeding at least once? 1 minus Q power n is the formula. When you write this in percentages, it is called hydrologic risk. This definition is also very important. With what return period a particular weir or bridge or spillway must be designed so that the risk will not exceed 20%. Risk will not exceed 35%. If you know the value of hydrologic risk, this equation multiply with 100 will give the hydrologic risk. You can calculate the return period. You can take the suitable precautions. Third chapter is very, very important chapter. This is very, very important chapter. Fourth chapter is evaporation chapter. Fourth chapter, evaporation chapter. In this particular chapter, in the chapter of evaporation, generally question will be asked on pan evaporometer method. Pan evaporometer method is the in situ method or field method on the bank of the water body from which the rate of evaporation is expected. In the olden times, about 15 years back, mass balance method and energy balance, mass budget method and energy balance methods are given. Recent times, they are asking only on pan evaporometer method. So that is the formula for E pan is equal E plus or minus Z. Once I know E pan, E from the surface of the water body is equal pan coefficient multiply with E pan. American based 0.7, Indian standard based 0.8 will be the pan coefficient. I know evaporation rate from the water body. You know what is the rate of evaporation? Volume of the water dissipated into atmosphere in the form of vapor by surface area of the water body into time of evaporation. Generally, millimeter per day is the unit we are going to get for the rate of evaporation. Transpiration is not that much important. Only thing is transpiration is measured only during the daylight hours. What is the device we use to measure the rate of transpiration called phytometer? Evapotranspiration, there is also the part of evaporation. We use lysimeter. Evapotranspiration is a little bit important. Evapotranspiration are consumptive use, which again gives the two aspects of the soil moisture. Potential evapotranspiration, which is nothing but the status of the soil having the sufficient moisture needed for the complete growth of the crop. Potential evapotranspiration, PET. Actual evapotranspiration is any intermediate status. Potential evapotranspiration is the maximum possible safety status, nothing but the field capacity of the soil. That's why measurement of PET is more important than AET. We have got two formulas. One is the Penman's. Penman's includes the mass transfer, heat transfer and mass transfer methods. Generally not adopted. BC equation, Blaney-Cadell equation, K into P into Tm by 100 is one important area. The names of the devices are important. To measure the rate of evaporation from the water body, we use evapometer. To measure the rate of transpiration, phytometer. To measure the rate of evapotranspiration from the land evaporation and plant evaporation, lysimeter. Evapometer, phytometer, lysimeter. Match the following may be given. More than one correct answers may be given. Like that, the typical questions you must practice. Numericals in the evaporation chapter and Blaney-Cadell equation also equally important for your gate preparation, my dear friends. What important points are needed regarding infiltration? You must understand infiltration capacity of the soil, FT and FCT, and what are the various methods available to calculate the rate of infiltration. Field methods are not giving the reliable values. Rainfall simulator is one laboratory method. Horton's infiltration capacity curve, there is also one good formula. FCT is equal FC plus F0 minus FC into e power minus KT. Area under the Horton's ICC will give the total depth of infiltration. and the two indices, W index and phi index. W index is the new revised value, new revised version of phi index. Phi index is obviously more. Phi index is calculated during the times of the rainfall. During the times of the rainfall when it exceeds W index. When there is a runoff produced because of some rainfall, that is called effective rainfall existence, we see W index and phi index problems are important. You must and should practice minimum 10-15 models. 10-15 models on W index and phi index. For the given catchment area, phi index is taken as the standardized value. If there is no data available from the catchment, you can take it as a 0.1 centimeter per hour is the value of phi index, assumed value. In which formula we are taking the initial losses in the calculation of W index. How do you calculate the runoff? From the Horton's ICC curve, construct hydrograph first. On the hydrograph, superimpose the Horton's ICC, area of the hydrograph lying about Horton's ICC, this hatched area will give depth of runoff. This method, construction or calculation of the runoff from the given catchment with the help of the Horton's infiltration capacity curve is very, very important for us. So, in this infiltration chapter, what are the various methods available? In situ method, single ring and double ring infiltrometers. Laboratory method is rainfall simulator method. Graphical method is Horton's ICC method. Construct hydrograph, superimpose the Horton's ICC, whatever area of the hydrograph lying above the Horton's ICC, get that area above the ICC, that total area of the hydrograph residing outside the Horton's ICC will give total depth of runoff in that given duration of the rainfall. Please recollect, vertical hydraulic conductivity is nothing but infiltration capacity of the soil. Vertical hydraulic conductivity. And also please remember one more basic point. If I is greater than Fc, F is equal to Fc. If I is equal to Fc, F is equal to I is equal to Fc. If I is less than Fc, actual rate of infiltration is equal to intensity of rainfall. Fc is the infiltration capacity of the soil. I is the intensity of the rainfall. F, actual rate of infiltration. Please recollect, actual rate of infiltration is the lesser value of intensity of rainfall and infiltration capacity of the soil. Infiltration, intensity of rainfall and infiltration capacity of the soil. This particular area also, generally questions are framed. Calculation of W index. Calculation of phi index also, you should practice the numericals. You should calculate, should have the sufficient practice over the numericals of this particular topic in the infiltration. My dear friends, runoff is not that much important. What is influent stream and effluent stream? What do you mean by virgin stream and non-virgin stream? What is meant by perennial, non-perennial and ephemeral streams? Such definitions are important. What are the catchment characteristics? How do you have the influence of size of the catchment on the runoff, shape of the catchment on the runoff, slope of the longitudinal axis of the catchment, time of concentration given by Kirpik equation? What do you mean by drainage density? What is meant by stream density? What do you mean by form factor? What do you mean by compactness coefficient? What is meant by drainage density? All these factors are important regarding catchment characteristics. Rainfall, runoff and catchment characteristics will be having under the same roof of same chapter, and some theory points are important. You must have the basic idea how the wind velocity will give the impact on runoff, how the orientation of the catchment will give the variation in the runoff, how the elevation difference will give the influence on the runoff calculation. Number of catchment characteristics are there. Then about the hydrographs. About the hydrographs, my dear friends, all the types of numericals you must practice. You must know how to get DRH, direct runoff hydrograph, flood hydrograph minus base flow. What are the various methods available for separation of the base flow? All the four methods you must know. Theory questions are being asked on process of separation of the base flow, which method is preferable, which method is given, recommended by IS Code and Central Water Commission. Such subtopic is important. Flood hydrograph, direct runoff hydrograph plus base flow. How do you get the area of the direct runoff hydrograph? If the nonlinear variation of the DRH is given, then divide into number of segments, as many number of segments as possible. Simply 0.36 into sigma O into T by A will give the direct runoff depth. 0.36 into sigma O into T divided by A. When the ordinates are taken with a constant time interval, when they are taken, direct runoff depth is given. When you divide each and every ordinate of the DRH with R, you will get the wonderful concept of unit hydrograph. When you collect the runoff data from the given catchment at the outlet of the catchment for some 30 years or 40 hours, get all the runoff volume divided by catchment area will give runoff depth. To get that R centimeter runoff depth, we are getting this runoff graph, hydrograph. If you want to get 1 centimeter runoff depth, the corresponding graph is unit hydrograph. Concept of unit hydrograph given by L.K. Sharman is one of the wonderful concept. What are the assumptions made? Apart from the general assumptions, like the area is having the uniform distribution, rainfall is occurring uniformly throughout the catchment, all the surfaces are plain, not uneven homogeneous soil must be available in the entire catchment. It should not exceed 5,000 square kilometers area. Apart from that common conditions, two basic assumptions are there. One is the time invariance, second one is the linear response. With increase in the time duration of the rainfall, how do you have the variation of the base period? That formula is also important. D2 is equal to B1 plus D2 minus D1 is the formula we get. With the help of this, as base period increases, maximum intensity of the runoff, maximum ordinate of DRH will get decreased. I repeat, with increase in the duration of the rainfall, duration of the runoff will increase. As a result, peak runoff discharge will get decreased. When the given unit hydrograph is taken as a triangle or a trapezium, suitable formulas will be having to calculate. The two formulas are very important. One is ordinates of unit hydrograph is equal to ordinates of DRH divided by capital R. If we want to get the ordinates of the flood hydrograph, ordinate of DRH plus base flow, then S-curve hydrograph is problem cannot be given. At the maximum, the problem can be given on Q equilibrium is equal to 2.778 A by D, A in square kilometers, D in hours. D is the duration of the rainfall of the reference unit hydrograph. Summation of that infinite number of unit hydrographs will give the S-curve hydrograph. Summation hydrograph, addition of infinite number of unit hydrographs, each of D hour duration. S-curve hydrograph, using the S-curve hydrograph, given the D hour unit hydrograph, you can construct a T hour unit hydrograph where T is equal to ND, but N is not an integer. Whether N is integer or not, Integer or fraction you can get provided the rainfall data is suitably given. Not possible all the times. You must remember some important concepts. You must get them printed in the mind. Regarding hydrographs, different typical versatility of the problems you must practice. Previous questions given in ESC papers and GATE papers. 2 times, 3 times you must practice, especially I request everyone to go through the chapter of hydrographs from all previous question papers. Here questions are important under graph. Which characteristics will control the rising limb, falling limb, crest segment? What do you mean by point of inflection on the hydrograph analysis? What is the use of cinders hydrograph? Cinders, synthetic unit hydrograph. These are important points on hydrographs. Next topic we discuss is, most important is groundwater hydraulics. That is, well hydraulics is very, very important. What is porosity relation? What do you mean by specific yield, specific retention? One important area you must know. How much water you can extract, how much water you cannot extract. Extractable plus inextractable is equal to total water. Total water in the case of saturated soil is nothing but porosity. So N is equal simply SY plus SR. Aquifer, aquitard, aquiclude, aquifuse, very important definitions. What is the confined aquifer? What is unconfined aquifer? What is the change in the groundwater storage? The relation between permeability and intrinsic permeability. What is the formula available for intrinsic permeability? From a radial well, how much water you will get from confined aquifer, from unconfined aquifer? What is the formula for coefficient of transmissibility? K into B in the case of confined aquifer, K into H in the case of unconfined aquifer. What are the tests you are having? Tests on wells. One is the pumping test. Why it is conducted? To find the specific capacity of the soil. Definitions are important. Specific yield, specific retention, specific capacity of the well. Those two are for aquifer. Storativity or storage capacity, transmissibility, all these definitions are very important. Second one is the recuperation test. How the aquifer will get recharged when you stop pumping operation for some time. Within what time, how much is the recharge of the aquifer will take place. Time of recuperation T. All these areas you must concentrate regarding the well hydraulics. Maximum flood estimation. Ravi's formula and Dickens formula are important. Dickens formula for North India and Central India. Ravi's formula for South India and part of Central India. they are important. And Gumbel's method, xt is equal to, for Gumbel's method, xt is equal to x bar plus kt into sigma. Application of this formula थोड़ा सा practice करना चाहिए. Flood routing, in flood routing, Muskingum method and Muskingum method formulas are important. In flood routing, very rarely they will ask the questions, but you can have a visit or revisit once or twice. What is the difference between hydrologic and hydraulic flood routing? Why it is not adopted, why it is adopted? In this again, reservoir flood routing, channel flood routing. For us, most important is channel flood routing. The method is Muskingum method. Friends, thoda sa jankari, some information you must get about the channels flood routing, channels hydrological flood routing by Muskingum's equation. S is equal K into xi plus 1 minus x into O. This is the differential equation given by Muskingum. From that, On is equal to C0 In, C1 In minus 1, C2 On minus 1 is the solution of this above equation. C0, C1, C2, 3 formulas are important. Remember, their sum is always equal to 1. If you know the present input, previous inflow, previous outflow, you can calculate the present outflow. Which of the following combinations of the parameters will control the present outflow? Present inflow, previous outflow, and the 3 coefficients C0, C1, C2. One is the routing time factor, delta T. The other one is the catchment factor, catchment or otherwise the stream factor, that is K. These are the important areas. If you are able to practice this, river gauging is not that much necessary. Where do you have the average velocity? That formulas are very easily rememberable. You can get those things written. Give proper weightage to hydrology. Have the good preparation, and every topic you prepare small subtopics. In every subtopic, what is the things to be learned, which are more important, which are more frequently asked. If you have the type of differential way of viewing the things, more important, moderately important, less important, great success will be awaiting for you. I wish your good rank will be published in the ACE results. ACE will provide the necessary support to you, and I wish all the best for you regarding this preparation. Good luck to everyone.